Hey everybody, this is Mr. Longo here, and this video is going to cover solving compound inequalities and sketching a little graph of the inequality. But before we do that, let's talk about the difference between an and an or statement. So let's just get off topic and go eat some pizza. So we're going to go to a pizza shop. And we walk in and we say, you know what, I would like sausage or pepperoni. So let's talk about what happens. The pizza comes out and we have sausage, so we're happy. The pizza comes out and we have pepperoni, and we're still happy because we said we'll take sausage or pepperoni. Another situation, we get half sausage and half pepperoni. We get both because we told them either or, so they said, hey, just have a little bit of each. We're still happy. Pizza comes out and we have just cheese. And we're not happy because there's no sausage or pepperoni. So, but three different options came out that we were happy about. Now let's talk about an and statement. So we go into that same pizza shop and we say, you know what, we would like a pizza with sausage and pepperoni. And the pizza comes out, it's just got sausage. We're not happy. Pizza comes out, we just have pepperoni. We're not happy. Comes out and it's just cheese. We're definitely not happy. If it comes out and it's got sausage and pepperoni, we're happy. So and statements are a lot more specific, okay? Ands are much more precise of what we're looking for. So now let's jump into the math world. An or statement. To work with a compound or statement, basically what happens is any number that is less than a -3 or a number that is greater than or equal to 2 would work. So let's just test out some numbers. How about -10? Yep, that works. How about -5? That works. How about 0? No, that doesn't work. How about 2? Yep, that works. How about 10? How about 1,000? Anything except for the numbers in between -3 and 2 would work. So there are a lot more options. -5 million is true for this or statement. Okay, so the only time it's false is when it's not on a line. But now we need to talk about an and statement. Remember, and needs to be very specific. So an and statement, and we're going to write a compound inequality. Basically, an and statement, you need to satisfy both of these constraints. So if x has to be greater than -3 and less than or equal to 2, then another way we can write this is we can switch this guy around and say that -3 is less than x, and x is less than or equal to 2. But this compound inequality writing can only be done for an and statement, not an or statement. Okay, so let's go graph this. So we still have the -3 and 2. But this time, x has to be greater than a -3, and it has to be less than or equal to 2. So when you have an and statement, you look for where both cases are true. So our final answer, or our third tier graphically, is only between -3 and 2. So you can go test this again. So we did this little true-false over here. Would -10 work? No, it wouldn't work, because it needs to be greater than a -3 and less than or equal to 2. So -10 only satisfies one of them. What about 0? 0 does work. 0 works. It's in between these two. 2 works. -2 works. -1 works. -3 doesn't quite work, but -2.99 does. And how about 10? Nope. 10 does not work because it's not less than 2. So this one, only where you have both of your inequalities that are true work. Okay, so in here, or statement, anything except for what's in between -3 and 2 worked. But in an and statement, only the few digits in between do. Okay? So that's the difference between an and an or statement. Now let's talk about how you solve them. You solve a compound inequality the same way you would solve a regular inequality. The only difference is sometimes you have 2 to work with, but it's no big deal. So, let's solve this guy first. 2x plus 4 is less than or equal to 6. Well, of course, we're going to subtract the 4 from both sides first, and we're going to have 2x is less than or equal to 2. Now we're going to divide both sides by 2, and we're going to have s is less than or equal to 1. In this one, we're just going to divide both sides by the negative 3. Remember, whenever you multiply or divide by a negative, you have to change the direction of the sign. So x is greater than 3. So we have our 1, we have our 3. This is an or statement. X is less than or equal to 1. And x is greater than 3. And that's it. For an or statement, we are done. We are not going to have a third tiered graph or anything because anything except for what's in between 1 and 3 will satisfy this inequality. When you are working with an and statement, and if it is a compound, all you do is you first subtract 8 from both sides, including the side, so in the middle. So like just solving, but you have 2 separate equations. So we're going to subtract 8 from everything. So that's going to give us a negative 6 is less than 2x, which is less than or equal to 4. Now we're going to divide everything by a 2. We have negative 3 is less than x, which is less than or equal to 2. So we have our negative 3, and we have our 2. X has got to be greater than a negative 3. And x is going to be less than or equal to 2. Now, our final answer for this compound inequality is only what's in between negative 3 and 2, but not including the negative 3. So this would be considered our final answer or our third tier. Now again, I know some people have done this in the past where you put these on top of each other and you just kind of color in the middle. Technically that is correct, but when we work with some of the complicated and special cases, a lot of times it's easier to just work with 3 tiers so you can see where the and statement has overlap or multiple answers. Okay? So, let's talk about a few special cases, and then we are done with this video. Special case number 1. X has to be less than or equal to 3, or it has to be less than 6. So we're going to start less than or equal to 3, or less than 6. So let's go back and talk about the or statements, where anything that satisfies one of them is technically correct. So let's start with a negative 10. Does negative 10 satisfy the first one? Yes, it does. Does it also satisfy the second one? Yes, it does. Let's talk about 4. Does 4 satisfy this one? No, it doesn't. But what about 4? Does it satisfy this one? Yes. So as long as it's true for one of the two in an or statement, remember, this is a compound, but it is an or, which means it's less specific. So your third tier on an or statement is whatever satisfies one or the other. So you'll have more options with an or statement. So you'll go with the bigger line. And that's because they're both going in the same direction. Okay? Let's talk about an and statement that goes in the same direction now. So we got the same 3 and 6. X has to be less than or equal to 3, and x has to be less than 6. So, an and statement, sausage and pepperoni, we need both to be satisfied. So, we'll talk about negative 10. Is negative 10 true for this one? Yep. Is negative 10 true for this one? Yep. How about 4? Is 4 true for this one? No, it's not. So anything to the right of 3 is not an option for the AND statement because we are going to be more specific, but it is true for this one. So as soon as we're false, meaning it's not satisfying both of our constraints, it is not true. So over here, our third tier is going to be only when x is less than or equal to 3. Okay? So remember, AND is more specific, so you have less options, so you go with the smaller graph. Last two special cases. Let's talk about an OR statement where x has to be less than or equal to 4, or x has to be greater than a negative 1. So we have our less than or equal to 4, and we have our greater than 1. So let's do some tests here. Does negative 100 satisfy this? Yes, it does, because it's less than or equal to 4. Does 0 satisfy this? Yes, it does, because it's in between negative 1 and 4. Does 10,000 satisfy this? Yes, it's greater than negative 1. So anything on this line technically works. Therefore, this is an OR statement where all possible numbers will work. So that's the all real number symbol. So any real number that you can think of will satisfy this OR statement, because it's either going to be greater than a negative 1 or it's going to be less than or equal to 4, which is already greater than negative 1. So there's a little bit of overlap, but every possible number will work. Okay, last one. Let's talk about another AND statement. This time the AND statement, we have to think of a number that is less than or equal to 5 and greater than 8 at the same time. Now, I don't know about you, but I cannot think of a single number that satisfies that statement. If you can think of a number that is less than or equal to 5 and greater than 8 at the same time, then you just worked out some sort of a miracle here. Because if we were to pick 0, 0 is definitely not greater than 8, so 0 wouldn't work. If we were to pick 7, 7 wouldn't work because it's not greater than 8 or is less than or equal to 5. And if we were to pick 10, 10 is greater than 8, but it's not less than or equal to 5. So remember, AND is the specific one. So this is a situation where we have no solution. So there are no answers that would satisfy this compound inequality. All right, that's it for compound inequalities. This is Longo, and I'm out. See you, bye.